All right, so here we're looking at section 3.5. We're really going to be solving some equations, and we're also going to be learning about some of our division properties here. So our learning targets, so these are kind of important. This is what we're really focusing on today. So first we're going to determine whether an integer is a solution of an equation. Then we're going to solve some equations using the addition and subtraction properties of equality. We're going to model the division property of equality to kind of see what that looks like. Then we're going to be solving equations using that division property. Then we're going to be turning some words into equations and then solving them. So really the first thing we want to be doing here is figuring out if a number is a solution. So the first thing I do to do that is how I determine that is the first thing is I say substitute that number in. When I do substitution, make sure you always use parentheses. So then I can simplify and solve. So let's look at this example. So this first example is determine whether each of the following is a solution to this 2x minus 5 equals negative 13. So let's look at part A here. So x equals 4. So I want to go and take this in and plug it in wherever I see an x. So I'll have 2, and we always use parentheses when substituting, minus 5 equals negative 13. So let's figure this out. 2 times 4 is 8, minus 5 equals negative 13. Simplify, 8 minus 5 is 3, is negative 13. This I know is not a true statement, so that is not a solution. And I always abbreviate solution as SOLN. You always want to come up with your own abbreviations to things so that you can not have to write everything over and over again. Okay, so now let's try the second part, this x equals a negative 4. So again, I plug it in and I'm just going to write it right here. 2, and I always use my parentheses, negative 4 minus 5 equals negative 13. Well, let's simplify and solve. And I know following my order of operations, I always multiply first. So 2 times negative 4 is negative 8 minus 5 equals negative 13. Well, negative 8 minus 5, both of my signs are the same, and I'm getting smaller. So I know if I'm on my number line, I start at negative 8, and then I go left 5, which gives me negative 13, equals negative 13. This one works. So yes, this part B, is a solution to this equation. And if you want, you can sit down and try it with this x equals negative 9, see what you get. Sometimes we'll have more than one solution to a problem, so it is possible. Okay, so here they're just walking through it. So here's a couple for you to try on your own. See what you can come up with for these ones. So now we're going to be looking at the second learning target, so using the addition and subtraction properties of equality. So here, remember, these gray boxes are really things that are going to be in your notes that I'm going to be looking for when we meet in class. Okay, so here's our subtraction property of equality and the addition property. So what this is telling me is, here's my subtraction property and my addition property. So if A equals B, so I have two things equal, so if I subtract the same thing from both sides, nothing actually happens. So same idea, I can add the same thing to both sides because that doesn't actually change my equation. So make sure you have something about that written down in your notes. So now we're going to actually use it. So now I'm solving. When I'm solving, my goal is to get the variable all by itself. So here I see I have y plus 9. So I see that I'm adding to my variable, so I want to undo that. And I know that to undo adding, I subtract. So I have y plus 9 equals 5. Well, so to undo this, I need to subtract 9. But I know using my subtraction property of equality, I have to do that to the same to both sides. Right? Because what I do to one side, I have to do the other side. What I do to one thing, I have to do to all things. So now I have y plus 9 minus 9, so my 9's go away. So I'm left with y equals 5 minus 9 is that negative 4. So here I have my y value, my y variable, all by itself. So I know that I'm solved as much as I can be. So we can always plug our numbers back in to double check that we were right. That's not always a necessary step, it's just something good to keep in mind though. Okay, so here's our next example, right? So I have a minus 6 equals negative 8. Well, I want to solve for a and get a all by itself. So I know that to do that, I see I have subtraction right here. So to undo subtraction, I would then add. So I'm going to add that 6 to both sides of my equation and simplify and solve. So when I have that, the values go away on that left side, so I'm left with just my variable, and a equals negative 2. So here you see a couple that you can try. So here's where the one that I want you to try right now. What do you get that y equals right here? Okay. keep going. So here's our next learning target, right? We talked about modeling the division property of equality. So far we've looked at equations where it's our variable plus something or our variable minus something. And I know that to undo that, I just either subtract for this example or I add for this example. I want to undo. So that's the same sort of thing that I'm going to be doing here as well. So we're just going to model this. We're just going to look at a picture first before we just dive into the numbers. So we're going to model this equation with envelopes and counters because I can put these counters in my envelopes. Okay, so I have two identical envelopes that contain the same number of counters. So I know that this is also kind of an equation. So my left side is equal to my right side. Okay, so to determine my number, I have to separate these on the right side into two equal groups. So my 6 counters divided into 2 groups gives me 3 in each, right? So if I have these in equal groups, there's my 2 equal groups. So I know that I have 3 in each group. So here's my equation that models that. I have 2x, so I've got 2 envelopes on one side, equals 6 counters. My goal is to figure out of how many counters go in each side. In each envelope, I'm sorry. So in order to do that, I go ahead and I separate them out like I did here. I made into even groups, and that's how I divide. So I divide both sides by 2 and I get x equals 3. Well, I also see that in my picture. So remember, we can always go back to pictures while we're doing this. So here's another example. So I see here I have 3 envelopes and I have 12 counters. So I know I want to break these 12 into 3 groups. Well, that's kind of done nicely for me. So I see that these 3 columns have the same number in them. So I know that here when I divide both sides by 3, because what I do to one side I have to do the other side, I see I have 4. And that's the same as 1, 2, 3, 4. So that's where I get. One way we can also think about that, and we'll think about that down here a little bit, is we're still undoing what has been done. Okay? So here's one I want you to try. I want you to write an equation for this one down here, and then try and solve it. So here's the equation that I want you to write. Go ahead and write this one and see what you can come up with, and then go ahead and solve it for me. Okay. So now here's another thing that definitely needs to be in your notes. Here's the division property of equality, right? So for any number, if I have a equals b, then if I divide by the same thing on both sides, I end up with the same equation, right? And I said earlier that we're just still undoing. So here I see I have my x and I'm told to solve, which means get the variable by itself. So here, since I don't see any math symbols, I know that I'm multiplying. So I know to undo multiplying, I have to divide. So when I divide by 7 on the left side, I also have to divide by 7 on the right side. And for this example, I know a negative divided by a positive will give me a negative value right here. So I end up with x equals -7. So then I can just substitute that back in to make sure I was right. So let's look at another one. Here I have 8a equals 56. So I want to solve, which means get the variable by itself. So I see it here, I'm multiplying, right? And I know to undo multiplying, I divide. So I have 8a equals 56. So I divide by 8, divide by 8. So a is equal to 7. Since both of these were positive, I know my result is going to be positive as well. Okay. So here's our next example. So I have a -3y equals 63. Same thing, I notice here that I'm multiplying. So I want to undo that, and to undo that, I divide by that -3. I'm always going to be dividing by the thing, the value that is with my variable, because my goal is to get my variable by itself. So here's one that I want you to try. So what do I get if I solve this value right here? Okay, so here we are for our final learning target, right? We're going to translate an equation and solve it. So translate and solve. 5 more than x is equal to -3. So a couple of things we always want to be aware of is whenever you see that word is, that's where our equals sign goes. So here they actually told us it is equal to, but sometimes you won't actually be given that. So if ever you see the word is, that's where equals comes into play. So let's translate it. 5 more than, and I know that more than means I'm going to be adding, then x is equal to -3. So I always kind of write my sentence first. So now I'm going to solve. So I see I have my x value on this left side. And I see that I'm adding this 5 to it. Since there's no number or value or negative sign here, I know I'm adding. So to undo this addition, I subtract 5, and what I do to one side, I have to do to both sides. So I'm left with x equals a -3 minus 5 gives me a -8. So then I can plug that in and double check again. Okay, so here's some that I want you to try. I want you to try and come up with first my translation of this one right here. So translate it and come up with an equation and then solve it. So here's some other words we need to know, right? So here's another is, so I know that that would be where my equal sign goes. Difference is a big thing, is I'm subtracting. So one thing we're going to look at is in your notes, we're going to come up with a list of words that we need to know that will help us to understand, am I adding, subtracting, multiplying, dividing? And I'll get you that here at the end of this video. Okay, so again, I just know the difference of n and 6, so difference means I am subtracting, is, that's where my equal sign goes, and then I solve it. So same thing here, okay? Product. Product is another word we need to know. Product means multiply. So then I know that I'm multiplying the number 108 is the product, again, is, here's where my equal sign goes, -9 and y. So then I can substitute those in and solve. Okay. So here we go. We're going to come up with our list of words that we really need to know. And then we're going to go check in on our learning targets. Let me make sure there's nothing else down here. Nope. Okay. So some of the words that we really need to know. This is always fun when this happens. Okay, it went too far. Okay, so some of the words we need to know. How do I know if I'm going to be add? One of the words that I know is sum. Sum is the product, or sum is the answer when I add. So if I see the word sum, I know I'm going to add. If I see the word difference, that means I'm going to subtract. If I see the word product, that means I'm going to multiply. And if I see the word divide, dividend, or if I see the word quotient, that means I'm going to divide. So some other words that I want to get you in the habit of knowing is, remember we talked that is the same thing as equals. Another word that we're going to see a lot is whenever you see the word of. When you see the word of, that means you multiply those things together. Okay, so another thing that we can do for add, right, more than. Another subtract would be less than. So I want you to, in your notes, make sure you have all of these words down in a way that you can see them and know what they mean. Also try and think of, we're going to add to this list as we keep going, of what are some other words that give us key hints on what we're actually doing. So now let's just go double check our learning targets before we finish. Okay, so first we determined whether an integer was a solution, and by doing that we always use our parentheses and just plug it in. So we got that one. So solve equations using the addition and subtraction property. Just remember we are undoing whatever's already been done. And that we also did here too with using the division property of equality. So we looked at envelopes and counters for modeling. That's just how can we turn it into a picture to make it make sense. Then we looked at our list of words and we translated to an equation to solve. So we're going to continue adding to this list of words to really help us get a firm grasp on what we're actually doing here. Okay, so now that we've walked through all of these learning targets, you should feel pretty comfortable being able to do all of these things. So now it's time to either move on to your homework or those con skills, or really what the next thing you need to be doing is.